Management of common high tunnel tomato diseases. So our first question is, what exactly is a disease? Well, in short, disease is a symptom. It is the reaction of a plant. It's that abnormality that we see, that we as farmers experience as that plant is infected by a plant pathogen, such as fungi, water molds, bacteria, viruses, nematodes, etc. So disease versus infection, those are two different things. In order for us to have disease, we envision it like a triangle. We call this the disease triangle in order to visualize what's needed. So in order to have disease, we must have three things. We must have the plant pathogen, we must have a susceptible host, and we must have a favorable environment for that entire process to occur. So if we were to break one side of that triangle, in theory, we would no longer have disease. So as we think about management of plant diseases, we consider how we can break one or more sides of that triangle. The plant pathogen, as I mentioned earlier, being the fungi, bacteria, viruses, etc. The host can be a susceptible plant part, a susceptible cultivar, or a susceptible species. And the favorable environment is what we consider as moderate temperatures and free water. So moderate temperatures being if we're comfortable, typically that plant pathogen is comfortable. And free water can be anything from high humidity, irrigation water, rain, fog, dew. And in order to manage plant diseases, we think about that disease triangle. We think about the biology of the individual plant pathogens, and we use that information to manage plant disease. We can't manage plant disease alone by fungicides. We must understand that life cycle, and we must use that information to break that disease triangle, to break one or more sides of that disease triangle. So let's use some examples as we consider some of this approach. So I'll start with foliar diseases, and we'll consider bacterial diseases as our first example. I've lumped bacterial spot and bacterial spec together. They are often the most common bacterial diseases that we see in high tunnel tomato production in Kentucky. So with bacterial spot and bacterial speck, typically both or either are introduced through seeds and or through transplants. So we see a lot of it coming into our high tunnels through transplants. Once the disease or once the bacteria are introduced into high tunnels, they can overwinter in debris or in weeds or in volunteer seedlings at any time. These bacteria both favor leaf wetness. Anything above 85% relative humidity is pretty much that target favorable environment that we talk about. For bacterial spot, the bacterium favors temperatures at about 75 to 85 degrees, and bacterial spec bacterium likes it a little bit cooler, 65 to 75 degrees. And both of those temperatures are pretty much what we typically see in high tunnel tomato in spring and early summer in Kentucky. In order to manage bacterial spot and speck, again, I'm lumping them together, we must start out with clean seeds and or clean transplants. Avoid bringing these pathogens into our high tunnels is absolutely critical. Resistant cultivars are available for bacterial speck, and I highly encourage any grower who has a history of bacterial speck in their high tunnels to go with resistant cultivars. Again, there are several available on the market. Humidity management is absolutely critical. So all high tunnel growers should be at all times monitoring humidity inside their tunnels and be prepared to manage that humidity by exchanging the air, by venting those high tunnels, often regardless of what the temperatures are outside. So to keep that humidity below that 85% threshold, ideally below 70% is what I would like to see to help manage other diseases as well. It's uncommon that we have overhead irrigation in high tunnels, but there are a few cases that I've seen, whether it's hand watering or supplementary irrigation, but always avoid wetting of any foliage of any kind, and for that matter, never work in plants that are wet, physically wet to the touch. We're always going to use bactericides as preventatives in all tomato production. We will start using bactericides right 1 week after transplant, and we will continue using typically copper throughout the plant cycle, throughout the production cycle. Our next group of foliar diseases, again, I've lumped some molds and mildews together, some very common ones. Leaf mold, gray mold, powdery mildew are the most common, but we also see other leaf spots in high tunnel tomatoes and also in field production. So lumping them together and generalizing, most of our leaf pathogens will overwinter in debris. So any debris that falls to the ground during the production cycle and after the harvest and after cleanup of the tunnel at the end of the season. In general, most foliar diseases favor any relative humidity above 70%. Leaf mold really prefers a higher relative humidity, 85% and up. I like, though, to always use 70% as our threshold to really try to keep our humidity down, because that's where we see the most of our foliar diseases. In order to manage molds, mildews, and other foliar diseases, always start with resistant cultivars. Leaf mold and powdery mildew resistant is available in many cultivars, so always check with your seed source and always look for resistance, particularly for leaf mold. We see a lot of leaf mold in high tunnels, especially as that humidity remains really high. So I've said it with the bacterial pathogens. I'll say it again for fungal foliar diseases. Managing humidity is absolutely critical. Again, exchanging that air, circulating that air, lifting those sides or opening those end walls, even temporarily, to get that humidity back down. Absolutely critical. Fungicides should be applied as preventatives. We can use fungicides as suppressants, but always using fungicides as preventatives will really go a long way in crop quality and overall yield. So beginning a fungicide regime soon after planting is always a great idea. So here are some examples. These come from just general pictures on ways that we can exchange air, we can lift sides and end walls up and down and exchange air, sometimes very quickly if it's chilly outside, or when temperatures are warm, to open those sidewalls and end walls for longer periods. Our next group of diseases I'll just call soil-borne diseases. Most of these on this list, timber rot, fusarium wilt, fusarium root and crown rot, and rhizoctonia stem and root rot, are caused by fungal soil-borne pathogens, and Pythium root rot is an oomycete, or as we call it, a water mold. So I'm lumping these together. We're calling these soil-borne diseases because they survive and complete their life cycles typically in the soil, if not in the soil, near the soil surface. So overall, soil-borne diseases or soil-borne pathogens favor wet soils. So anything above about 70 or 80% saturation point. So wet soils are really going to activate and allow these pathogens to break their dormancy and to germinate and actually produce the spores that will infect your healthy plants. In general, soil-borne pathogens are usually introduced and they begin at low levels, and as long as we have hosts there, especially if we're not rotating out of susceptible hosts, they will build up over time. So that's why we see new high tunnels are usually fairly disease-free, but over time we always see that increase in amounts of disease. And that's because soil-borne diseases, again, they build up in over time to very high numbers in some cases. In general, soil-borne pathogens will overwinter either in the soil or in debris that's on the soil surface. Rhizoctonia, the pathogen Rhizoctonia, about 2 or 3 years survival without a host. Fusarium, the wilt pathogen, 3 to 5 years. Eurypithiums, about 4 years, and Sclerotinia, which is the causal agent of timber rot, 5 to 7 years. So even without a host, these pathogens can really survive and persist for very long periods. Their optimal or preferred temperatures for activity, the Sclerotinia, the timber rot pathogen, cooler soils, 55 to 65 degrees Fahrenheit. Rhizoctonia, a little warmer, 60 to 80. The wilt pathogen, Fusarium wilt pathogen, Fusarium oxysporum, 75 to 80 degrees Fahrenheit. And Eurypithiums, there's a very wide range because we have a lot of Pythiums available, but some of those a little bit warmer. In general, we manage the root and crown rots, or the soil-borne pathogens, in many cultural methods. Once those pathogens are established, it's extremely difficult. When possible, we will use resistant cultivars. So our fusariums, we will have resistant cultivars for fusariums, Fusarium wilt in particular. So if Fusarium wilt has been a problem in your high tunnel, you must absolutely begin with resistant cultivars. Unfortunately, we don't have resistance for many of the other diseases. Always be sure you're bringing in clean transplants. Know your source and make sure that whatever is introduced into your tunnel is a clean plant from the very beginning. I highly encourage rotation. Tomatoes are our most profitable high tunnel crop, especially that spring-summer crop, and so a lot of growers don't want to rotate out of tomatoes, but a 3-year rotation is ideal, particularly when you have very high levels of soil-borne pathogens built up in soils. Sanitation is also very important, so keeping things clean, cleaning your tools in between tunnels, always working in the clean tunnels first before moving into those that are infested or contaminated. Not bringing any sources of soil like your tools or implements from one tunnel to the next, so not transferring any soil or any kind of debris that can transfer those fungal propagules from one tunnel to the next or from the field to the tunnel. Once you do detect disease in tomato plants, getting rid of those plants, so roguing those plants out as soon as possible, not giving those pathogens an opportunity to develop spores and to keep building up in those numbers. Removing that debris right away. Anytime you're doing any kind of pruning or any kind of roguing, get those plants and that debris out of the tunnel. Never throw it in the centers, never leave it there. And that being said, at the end of the season, getting all plant material out right at the end of the season and hauling it away, never leaving that inside the tunnel. In between crops, tilling and plowing. A lot of times these propagules can be buried, so tillage is a very important part of management of soil-borne pathogens. So again, the higher those numbers are, the more intense a grower might consider some of these management practices. Remember, I said earlier that our soil-borne pathogens usually favor wet soils. So keeping your drainage at about 50% or lower in water holding capacity, so not overwatering, not keeping things too wet. We do see a lot of tunnels that maybe will get a little bit flooded or a little bit saturated, maybe on the low end. So think about not just the water that you're putting in the tunnel through your irrigation, but also what the surface drainage looks like outside the tunnel and in the surrounding fields. And then finally, fungicides used preventatively, or if you do have an outbreak, to use them as a suppressant. Fungicides are never going to cure disease. So if you have a history of any of these soil-borne pathogens in your tunnel to be able to use fungicide drenches to protect your plants before infection occurs. But if you do have an outbreak, remember that fungicides are going to only suppress at the very least. So soil-borne pathogens are very difficult to manage. So you can get some suppression from fungicides, but really the goal is to just get through the season as well as possible with the best yield possible, and consider all of the cultural practices, including rotation, in the future. So here are some examples of some really negative situations: flooding and even weed buildup or poor maintenance inside and right outside of the tunnel. So keeping things clean, a good sanitation program, a good drainage to be considered when building the tunnel. And then of course between seasons, tilling is it can really go a long way to help manage soil-borne pathogens. Deep tillage, that is, not just bed shaping. So with that, I will close in reminding everyone to check out our plant pathology website. The UK Department of Plant Pathology has a lot of resources if you just click Extension Publications. And we do have a lot of resources there, a lot of fact sheets that describe life cycles of some of these pathogens to help you understand what's going on and allow you to use that information for cultural management. We also have spray guides, including ID 36, which is the Kentucky Vegetable Production Guide, and it is always available on our website and by hard copy through your local county agent. I also encourage you to familiarize yourself with both ID 36 and the Southeastern Vegetable Crop Handbook, or we call it the SEVU Guide. In both instances, we list fungicides that are appropriate for high tunnel and greenhouse production. I will remind every grower that not just any fungicide can be used inside high tunnels. High tunnels are considered greenhouses, and so growers should always use products that are approved for greenhouse use. And in ID 36, the Kentucky Vegetable Production Guide, you will see those greenhouse fungicides listed on page 18. And in the SEVU Guide, page 293, we'll show the greenhouse fungicides, and then an efficacy guide for greenhouse tomato diseases on page 309. So I highly encourage everyone to check out those resources before moving on to just using your typical field tomato fungicide guide list.